Hi students, welcome to Science Extension and Module 3, the Data, Evidence and Decisions. This is video number 4 and we're going to look at some of the different ways that we can represent data. Students need to be able to select and use appropriate tools, techniques and/or models in order to manipulate and represent data appropriately for a data set, including but not limited to spreadsheets, graphical representations, models and digital technologies. So there's quite a few things here. So we want to make sure that we try and cover each of these in just a little bit of detail and give you a chance to have a look and explore each of these different types of techniques. So in the last video, we were looking at descriptive statistics. Now we want to see how we can represent data, perhaps some of the ways that we can manipulate data and then represent that data in our reports. So data representation is the particular form in which you store, process, analyze, and present your data. Once you've collected it, your data needs to be organized and it needs to be displayed in a form which enhances communication, which means that people can very quickly pick up your work, have a look through your data displays and get a bit of a feel for what it is that you found. And hopefully what they will do is draw similar conclusions from the data that you have. All of your data may initially be in simple tables in an appendix, and this can be done in something like Excel, which we will talk about in this video. But it can also be manually kept by hand too. It just depends how much data you're collecting and also whether you're sourcing that data yourself, whether you're doing a first-hand investigation or whether you're gathering that data from one of the many public online data sets. In the main body of your report, you need to select a way of presenting your data that draws the reader's attention and helps them to visualize the relationships that you're investigating. So there's 4 ways that are suggested that you might look at representing your data in some sort of a visual way. And whichever of those that you choose, I would encourage you very much to at least start with a spreadsheet, particularly with an Excel sheet, numbers if you're using an iOS system, maybe even the sheets that are available through the Google network of apps. It doesn't really matter as long as you've got something which doesn't just allow you to store the data, but also allows you to do some manipulation with it. Now, spreadsheets are just large sheets with lots of cells in grids of rows and columns. You can put words, you can put numbers, you can put formulae, you can actually carry out statistical testing, which we'll look at in later videos, into each of these different types of cells in order to create a whole display of graphics for your report. So this can include things like graphs, charts, tables, headers on tables, and also statistical analyses that make the whole process of presenting and analyzing your data so much easier. You can adjust grid lines to make some cells bigger than others. You can merge cells, you can create headers as I've mentioned. There's lots and lots of different things you can do with spreadsheets. Pretty much anything you can do with a word processor you can do with a spreadsheet. And there's often a lot more options too. And if you're smart at doing things like macros, then you may get even more out of your average spreadsheet. The most important thing that I like about using something like Excel, that's of course Microsoft Excel, is its compatibility. So it fits very nicely between different types of Microsoft packages. So that is, you can take Excel, you can import it into Word, and you can get all the formatting very, very nicely, and they talk to each other, these different applications. And so it's quite a seamless way of being able to collect your data in certain places, do certain things in certain different types of apps and bring them all together in the one final document. And of course, that is very, very valuable. For my own PhD, I used Excel, partly because I was familiar with how this worked, but also because of the great variability in what I could do with Excel. And you can see one of the things that I looked at was training methods. So different ways that people would prefer to collect expertise around using ICT in their teaching. And that was one of the things that I was looking at in my own PhD studies. Because Excel's part of the Microsoft suite, it has that great cross-compatibility, which is really important, as I said. It has a lot of tools for analyzing, for organizing, for presenting data, and they are very nice and clean visual forms. As I said, whether or not you continue on to do your graphics through Excel, I would still at least be collecting some of your data in Excel because it's just a nice, neat, easy way of being able to store lots and lots of information. The advantage too is if you use a cloud server, particularly if you've got a school account, for example, that you can link into a OneDrive account or something where you can keep things on the cloud, you won't lose your data. And that is one of the critical things that happens a lot, nearly every year, for people, not just high school students, university students, who think they've got everything backed up and find at some point they've lost data. So it's really, really important to try and make sure that you've got a way of storing your data that is as foolproof as you can possibly get it. And storing things on a cloud, particularly in these applications, the 365 applications, for example, that allow you to keep things on the cloud and access them from different machines, I think is really, really important. The other advantage of using something like Excel is that you can also import things like CSV files. So where you find public data sets where there's lots of information, something like the Titanic data that we talked about previously, you can bring that into Excel and then you can start to manipulate that data, to organize it, to cleanse it, to start to do statistical analyses on it, even simple things like the calculations of a range or a mean or a standard deviation. And Excel has a range of fantastic statistical tools that help you to do this. The other nice thing with Excel is it very seamlessly moves from that table of data into some of these graphical representations. So you can see what I've done here is I've looked at a range of different types of values that I've looked at for all the different types of training methods that I was looking at. And you can see on the same graph, I've been able to put a mode and a mean. That gives me a little bit of an idea of the sorts of scores that I was getting from different groups, looking at both maths and science teachers and the way that they preferred to get information around how to use technology in their teaching, and just some of the different options that I gave them. So this is a way of kind of seeing that you can use multiple different types of graphs, put them together in order to sort of see some different trends occurring as you work through each of these different values. So the graphical representation then is just a simple form of a diagram or a chart that shows some sort of relationship. Remember, part of what we're going to be looking at in this section is the difference between correlation and causation. Is there a relationship between your two variables, your dependent and independent variable? Are they showing some sort of correlation? Are they doing something similar in relation to each other? And is there a causal relationship? Is one actually affecting the other in any way, or is there something else going on? The first way of being able to determine relationships between different variables is to put them in this sort of a visual format that we can generate in something like Excel and then be able to look at some of the patterns that we're seeing. One of my students this year is looking at building models of bird flight formation, and so this was a nice model that I found in one of the papers that we were looking at for him. To try and get an idea of how models might also be something that you might consider using in terms of, again, a visual representation for what you might be exploring as part of your inquiry question. Scientific models are simplified abstract views of more complex realities. They can have a tendency to oversimplify things at times, so it's important to remember that models will have limitations, but they can also be very, very valuable to scientists in trying to understand some of the different relationships. They can also be used for explanation, for prediction, for testing of different variables, different computer programs, for mathematical equations, to try and get a little bit of an idea about what might be going on in a particular situation. Models can also help us to understand the very, very large, such as things on the scale of the universe, and also the very, very small. And we've all studied models of atoms, even if that was in the younger years, in 7 to 10 years, you still would have done some atomic modeling, even if you haven't been doing chemistry. So models can be physical, they can be computational, they can be generated in computers, or they can be mathematical. And NISA itself defines models as representations that describe, simplify, clarify, or provide explanation of the workings, structure, or relationships within an object, system, or idea. Now, this is, of course, a very complex way of describing models, but nevertheless, models are just about some visual way of representing some sort of idea we're trying to investigate. And remember, there are real advantages to being able to use some sort of a physical model you can manipulate, particularly if we're looking at things as small as the atom. But there are also going to be limitations associated with modeling. Finally, digital technologies. And digital technologies often go hand in hand with models because we can use digital technology to actually create computer-generated models. And this is particularly important for things like predicting future climate, looking at rainfall patterns, looking at the movement of different air masses and trying to understand the impact that they might have, maybe predicting future La Nina or El Nino events that are going to cause either considerable amounts of rain in a La Nina event or droughts in El Nino. Data representation means discrete representation of information using number codes. So a lot of what digital technology does is it reduces all of those complex variables down to simple codes. They can include characters, images, sounds, or instructions that can be manipulated, stored, or communicated by digital systems. These can then model quite complex processes, and you can see a good example one here from NetLogo that has looked at how peppered moths might change. So this is an investigation of microevolution, how the color of moths in a population might change in response to different types of environmental factors. And you can see the nice thing about this is there's a series of things that we can do in order to try and change the variables or change the parameters, the initial conditions, and how they might change over time. We can kind of get some sort of a visual on various numbers of lighter and darker colored moths, but you can also see there's a generation here of one of these little graphical displays, a nice real-time graph that occurs as you run this particular simulation, so you can see how numbers are changing over time, what's happening in response to pollution, and how that might have an effect on the population of particular species. There's a number of different types of simulations, and you might find that one of these is actually useful for you to help you investigate the problem that you've set for yourself. Either way, it's worth having a bit of an explore at some of these different types of models to help you understand both the value of these different types of visual displays and also their limitations. Thanks for watching.